Hello, welcome to lesson 5, radio frequency measurements taken in free space. So in this lesson we're going to look at free space measurements, we're going to look at anechoic chamber measurements, and we're going to look at a real-life example of an anechoic chamber. One that I used to spend half my life in, and another one which is pretty impressive. So why do we need free space measurements? So when you have a horn antenna, quite often you need to transmit from this horn antenna, or you need to receive from this horn antenna. You can't do that in a small box. So antennas have something called a near field. If you take a measurement in the near field, your measurement is not going to be accurate for how it behaves in the far field. And you want the far field because you want to be a long way from the antenna. So you need space, which you can get on an outdoor test range. Also, sometimes you want to measure as a function of angle, so you don't just want to look directly down your antenna, you may want to see what the performance is as it moves around. So outdoor test ranges do not look this swish. They're normally on air bases, in the middle of nowhere. I thought this looked a bit more attractive. They're all very, very similar. You have a transmit horn high off the ground, you have an antenna under test high off the ground. You want to get away from the ground because you get a lot of reflections from that. These are large, these are expensive, and they're very difficult to work on because they're outdoors and they're remote. So you have no backup. The place that I used to work had no running water, for example. We were an hour and a half away from site. You had to take all your tools with you. You had to be very meticulous, very carefully planning. And you had to be very safety conscious because not only were you working with RF radiation, you were working at height as well. What you find is anything in the vicinity of where you're testing will give you reflections. So if a farmer in a nearby field puts up a new fence, that gives you a new reflection. You need to account for that in your measurements. Anechoic chambers are rooms which try to mimic the outdoor. So your outdoor measurements are great, but they always come up in winter and it's always horrible to go and do them. Anechoic chambers you can use any time of year. It's a room which is lined with RAM, radio absorbing material. So this is the foam loaded with carbon that absorbs that material, and you can see they're nice and squishy. They are expensive anechoic chambers, that's true. But they're normally set up in the lab, so you have all your facilities around you there, and life is much easier working in an anechoic chamber than it is a free space test site. You have to design them very carefully though. They are unique to the size of the frequency of the antenna being measured, so you can't just shove any antenna in any anechoic chamber. It doesn't work. I will be actually doing a separate course on anechoic chambers and the kind of things that you need to consider when you're designing them. So if you're interested in that, have a look at that one. So I used to spend half my life in this anechoic chamber. It was great. I really enjoyed it. So you can see we've got quite large spikes on the wall. We've got a positioner, which is the metal thing to my right, which moves our antenna around. The cardboard box behind me wasn't normally there, so do ignore that. That shouldn't be there. The positioner allows you to move the antenna around, so you can do different measurements at different positions, and all of this was actually automated by computer. So you could load up a suite of measurements to do, press go, go home for the night, come back the next morning and have a whole host of data to analyse. So we used to take lots of different kinds of data. I'm just going to show you one example, which is a swept gain. So this is a gain swept over frequency. And what you'll see is that there's two different measurements for our magnitude and our phase. We have a magnitude on the left-hand side, which is gain. We have a phase on the right-hand side. And you can see there's much more variation on the phase than there is on the gain, which you would expect. So anechoic chambers come in all shapes and sizes. You can get some huge ones that fit massive military vehicles like this in. They've got lots of antennas on, so you need to test their performance and their interference with each other. Okie doke, so conclusions. Free space measurements are measurements taken outdoors. Anechoic chamber measurements try to simulate this outdoor measurement, but they're much more convenient to use. Okay, so in the next video we're going to sum up everything that we've learned in chapter 1.